Dear students, I welcome you all to my today's class. Today we discuss very important and very interesting topic of this chapter, that is matrix multiplication. Knowingly or unknowingly we are apply this matrix multiplication in our daily lives. Let's consider one example here. There are two persons X and Y. Both are purchased some items, that is X wants to buy two pen and five books, and Y wants to buy eight pen and 10 books. Okay, they both go to a shop to enquire about the rates, which are quoted as follows. Pen is quoted as rupees 5 each, and book is quoted as rupees 50 each. Then how much money does each need to spend? Clearly, X needs rupees. She wants two pen that costs 5 rupees and 5 books that costs 50 rupees. So the person X requires total rupees 260. Okay, this is person X. Then this person Y requires, there are 8 pens, each pen is 5 rupees and 10 books, each book is 50 rupees. Okay, total rupees 540. In terms of this matrix representation, we can write the above information as follows. Requirements, this is the requirement. Okay, this is prices per piece, and this is money needed. Okay, so requirements, X requires 2 pen and 5 book, and Y requires 8 pen and 10 books. So this is one set. Prices per piece, for pen 5 rupees each and for books 50 rupees each. So I also represent this is in matrix notation. Then total 5 into 2 plus 5 into 50. Another one is 8 into 5 plus 10 into 50. So this is one more matrix notation. So this is equal to 260 and 540. So we can represent by the matrix. Okay. So this is possible. This multiplication, this calculation is possible only when depends on these orders. There is some conditions here. Let's see what is the condition, or what is the condition for the matrix multiplication. Okay, this calculation, for what is the condition for this calculation. So that is the definition of the matrix multiplication. So the matrix multiplication is defined as, for any two given matrices A and B, we say that the product AB exists only when the number of columns in A, the number of columns in A equals to the number of rows in B. Number of columns in A equals to the number of rows in B. So when AB exists, we say that A is conformable to B for multiplication. Okay. The condition is like this. If A is a matrix of order m by n and B is a matrix of order n by p. Note that all these are different here. Suppose all these numbers are different. Number of column of A equals to number of rows in B. Number of columns of A equals to number of rows in B. Therefore, the product AB exits, the resultant order is M by P. Is it clear? Now, if I write the matrix B first, what is the order? Order is N by P. And write the matrix A. What is the order is M by N. Since all these numbers are different, in this, to explain here, I'll consider all these numbers are different here. P is not equal to M. In this case, P is not equal to M. Therefore, the product BA does not exist. The product BA does not exist. This is possible. Product BA is possible if P is equal to M. Otherwise, this does not exist here. So, we define the multiplication of the matrices as, let A is equal to Aij of order m by n and B is equal to Bjk of order n by p be two matrices such that the number of columns in A is equal to the number of rows in B. Then AB exits is of order m by p. Okay. So this exits here. So for any two matrices A and B, the product AB may exits and BA may not exits. Depend on the order we define here. Okay. AB and BA both may exist. One more point, AB and BA both may not exist. These are the chances here. So first we check the order, then we proceed here. Okay. Let's take one example. So for example, if A is a matrix, what is the order? Order of this matrix is 2 rows, 3 columns. And B is one more matrix, 3 rows and 2 columns. So show that both AB and BA exist and find AB and BA. To show that AB and BA exists, first check the order here. So here A is a 2 by 3 matrix, okay, and B is 3 by 2 matrix. Now compare the order. A is of order 2 by 3, that is number of rows is 2, number of column is 3. B is of order 3 by 2, that is number of row is 3 and number of column is 2. The product AB is possible only when the number of column in number of column in A is equal to the number of rows in B. Number of columns in A is equal to number of rows in B. Then the resultant matrix exists and is of order 2 by 2. First one and the last one. The resultant matrix is of order 2 by 2. What is the conclusion? Therefore, product AB exists and it is a order 2 by 2. Okay. Let's take this AB is nothing but C11, C12, C21 and C22. Order 2 by 2 means there are only 4 entries. Okay. What is C11, C12, C21 and C22? The first entry C11, this entry C11 is obtained the elements of the first row of A is multiplied with elements of the first column of B. Thus, entry C11 is first row of A into first column of B. I have to multiply the entries. How to multiply the entries? A11 into B11. Okay. A11 into B11. This one. Plus A12. Here this second entry. Here B21 is the second entry. A12 into B21. This one. Plus third entry of the first row. A13 into B31. So this is the entry C11. First row, first column. Multiply the entries of the first row by entries of the first column. That is the first entry of the product AB. Next one is C12. So C12 is lies in first row second column. This is the entry in first row second column. Therefore, we multiply the entries in the first row with second column of the matrix B. First row second column. This one C12. First row of A into second column of B. So A11 into B12 plus A12 into B22 plus A13 into B32. Okay, this is the entry. Next, C21. C21, that entry lies in second row first column. This entry lies in second row first column. That means to obtain the value here, we have to multiply second row of A with first column of B. Is it clear? Second row of A with first column of B. That is A21 into B11 plus A22 into B21 plus A23 into B31. This is one. That is C21. This entry. Next, the last entry. C22. So C22 is this entry. This lies in second row, second column. So lies in second row, second column. Therefore, multiply the entries in the second row with second column. A21 into B12 plus A22 into B22 plus A23 into B32. Therefore, C22 is second row of A into second column of B, and this is the end. Therefore, the product AB we directly write as it is. So, this is the matrix A and this is the matrix B. Here only we check the order. This is 2 by 3. This is 3 by 2. Here the middle two numbers are same. Therefore, the resultant should be first and the last number. The order of the resultant is first and the last number, 2 by 2. So, A11 into B11 plus A12 into B21 plus A13 into B31. Next, first row second column. So, A11 into B12 plus A12 into B22 plus A13 into B32. This is the second row first column. Second row first column. A21 into B11 plus A22 into B21 plus A23 into B31. And the last one is second row second column. So A21 into B12 plus A22 into B22 plus A23 into B32. So this is the matrix AB. Now, so AB exists and we find A into B. Now check BA. Is this the matrix BA exists? If it is exists, what are the elements of the matrix BA? This is B. What is B? Matrix B is B11, B12, B21, B22, B31, B32. So this is the matrix B. Okay. Then matrix A. We want BA here. And the matrix A. A11, A12, A13, A21, A22, A2. First check the order. First defines whether the matrix BA or exists or not. What is the order of this matrix? There are 3 rows, 2 columns. What is the order of this matrix? There are 2 rows and 3 columns. So B is of order 3 by 2 and A is of order 2 by 3. So middle two numbers are equal. Therefore, the resultant is of order 3 by 3. Therefore, BA exists, and what is the order? Order should be 3 by 3. So 3 by 3 entries you know. C11, C12, C13, C21, C22, C23 and C31, C32, C33. So there are 9 elements in a 3 by 3 matrix. Let's begin with the first entry. First row, first column. First row, first column here. Okay. First row, first column. B11 into A11. A11 plus B12 into A21. So first row, first column over. The next entry of the matrix is first row, second column. First row, second column. So this is B11 into A12 plus B12 into A22. The next entry is AC13, first row, third column. This is first row, third column. So first row, third column, B11 into A13 plus B12 into A2. Next, this is the second row, first column. Second row, first column, C21. Second row, first column. So B21 into A11 plus B22 into A12. B22 into B22 into A21. B12 into A11 plus B22 into A21. Next, second row, second column. Here second row, here second column. So B21 into A12 plus B22 into A22. Next, this is second row, third column. Second row, third column. So B21 into A13 plus B22 into A23. Last one. Next, third row, first column. This entry is third row, first column. Third row, first column. So B13 into A11. So B31 into A11. B31 into A11 plus B32 into A21. Third row, second column, B31 into A12 plus B32 into A22. Then this is the last row entry. Third row, third column. Third row, third column, B31 into A13 plus B32 into A2. So this is the product BA. So in this example, both AB and BA exists here. I'll consider one particular example here. If A is equal to 6, 9, 2, 3 and B is equal to 2, 6, 0, 7, 9, 8. Now check is AB and BA exists. Let us check AB. So what is the order of A? Order of the matrix A is 2 by 2. And what is the order of B? Order of B is 2 rows, 3 columns. So middle two numbers are same. Therefore, product exists and is of order 2 by 3. Therefore, AB, matrix AB is equal to 6, 9, 2, 3. Matrix A into matrix B, 2, 6, 0, 7, 9, 8. Multiply the entries. What is the order of the resultant? Resultant is 2 rows, 3 columns. There are 2 rows, 3 columns of this type. So first entry, first row, first column. First row, first column. So first row, first column. 6 into 2 plus 9 into 7. So this is first row, first column. Next, second entry that lies in first row, second column. So first row, second column. First entry 6 into 6 plus 9 into 9. And this is the first row, third column. This entry is first row, third column. First row, third column. So 6 into 0, multiply the first entry to first entry itself, and 9 into 8 plus 9 into 8. So this is first row over. Next, second row. This entry is lies in second row, first column. So second row, first column, left to right and up to down. Second row, first column. So 2 into 2 plus 3 into 7. Second row, second column. So 2 into 6 plus 3 into 9. This entry lies in second row, third column. Second row, third column. So 2 into 0 plus 3 into 8. Matrix multiplication is over. Now calculate the values. 6 into 2, 12 plus 9 into 7, 63. 6 into 6, 36 plus 9 into 9, 81. 6 into 0 is 0 plus 9 into 8 is 72. This entry 2 into 2 is 4, 3 into 7 is 21, 2 into 6 is 12, 3 into 9 is 27, 2 into 0 is 0 plus 3 into 8 is 24. What is the order? Order is 2 rows and 3 columns. So what is the final entry? Final entry is 12 plus 63, 75. 36 plus 81, 117. This is 72. 4 plus 21, 25. 12 plus 27, 39. And last entry is 24. So matrix multiplication A into B exists and the matrix is this one. Now check B into A. What is the order of B? B is of order 2 rows 3 columns, so 2 by 3. And what is the order of A? A is a matrix of order 2 by 2. These two are not equal here. Number of columns of the first matrix is not equal to number of the rows of the second matrix. Number of columns of the first matrix is not equal to number of rows of the second matrix. Therefore, this does not exist. So BA does not exist. This is about the matrix multiplication. Thank you.